Hello viewers, in this video I will be discussing numerical 6, okay, from page 128 of textbook class 9 standard, okay, of chapter 9, force and laws of motion, okay, force and laws of motion. From this chapter, from page number 128, numerical number 6 we are going to discuss. Okay, so what is the problem? Let's see. A stone of 1 kg is thrown with a velocity of 20 meter per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meter. What is the force of friction between the stone and the ice? Okay, so what, by understanding the situation, what are the things given? First you need to check, okay, after that what to find out, then you can decide which formula to be used. So let's see what is given. A stone of 1 kg, that means mass is given, mass of stone. So we write mass m equal to 1 kg. First we write what is given, then what else given? With a velocity of 20 meters per second, this stone is thrown with a velocity of 20 meters per second. So velocity given, that means velocity of the stone given. So we assume this as initial velocity u, 20 meter per second. Why initial velocity? Because when the stone is thrown, initially its velocity is 20 meter per second. Okay, after that what velocity it has attained, we'll see. Lake and comes to rest after traveling a distance of 50 meter. That means how much distance the stone has traveled? 50 meter. So s, we denote s equal to 50 meter. After traveling 50 meter, the stone has comes to rest. If you see, that means after it gets stopped, it will have a velocity which is the final velocity, and that is 0. That's why final velocity of the stone is 0. Okay, after traveling 50 meter, the stone comes to rest, so it will have final velocity 0 and initial velocity 20 meter per second. So these things are given. What is the force of friction between the stone and the ice? That means we have to find out F. We denote force by F, and we have a very simple formula for F equal to m into a, ma, where m is the mass and a is the acceleration. So to find out force of friction, okay, if we are using this formula, we need mass. So mass is given, no doubt, of the stone. What is acceleration? Not given. This acceleration, if you can find out, then we can use this formula. Okay, so to find out this acceleration, we have to use another formula. Okay, which formula? Let's see. We know 2as equal to v square minus u square, one of the equation of motion. We have 3 equations of motion. Okay, out of 3 equations of motion, one of the equation of motion is 2as equal to, that is the third equation, 2as equal to v square minus u square. Okay, where s is known, v is known, u is known, you can easily find out a. That you have to build this ability, which formula is suitable for this problem, okay, particularly to find out acceleration. So since v given, u given, s given, I can easily find out a by using this equation of motion. So by cross multiplication, 2as equal to v square minus u square, cross multiplication, a will be equal to v square minus u square by twice s. Okay, by twice s. So just put the value, v is 0, 0 square, u is 20, so 20 meter per second whole square. You can also write without unit also, just at the end you have to put the unit properly. So 2 into mid 50 meter. Okay, since all the units are in standard SI unit, no need to do any changes here. So 20 square 400 minus 250 100. So if you see, it is minus 4 meter per second square. Here meter and meter cancel, s square remain s square. Okay, sorry, here it is minus 2. Okay, minus 2. So second inverse 2. Okay, and meter, so meter second inverse 2. So if you do not put the unit, you can directly just do the calculation at the end. What is what you have found out? A, acceleration. So what is the unit? SI unit of acceleration. SI unit of acceleration is meter, okay, second inverse 2. So directly you can put at the end, okay. So minus 4 meter second inverse 2. So since we have found out A, we already have M. Now we can use the formula F equal to ma to find out the force of friction. So according to Newton's second law of motion, what we have formula force of friction, that is F, we can write m into A, that is for ma. So F equal to, what is m? 1 kg, already given here in the question, you can see, okay, 1 kg, we also denote here 1 kg. So A we just have found out, minus 4 meters per second square, that is 1 into this, very simple, minus 4 kg meter per second square. Kg into this unit will also be multiplied, and kg meter per second square in one, you can write in one simple symbol, we can write n, that is Newton, okay. So minus 4 kg meter per second square is Newton. So we also know that 1 Newton equal to 1 kg meter second inverse 2, okay. So that's why, what is the force of friction? Minus 4 Newton, okay. And why it is negative? This negative sign indicates here, that the force of friction, the force is acting in the opposite direction. Since it is a force of friction, okay, since it is a force of friction, the force is acting in the opposite direction of the motion of the stone, okay, to stop it. That's why it is minus. So whenever you find out the force of friction, you will always find the result in negative form, okay. So this is how we should do this kind of numericals, okay. We have to understand the whole question, what is given and what to find out. Then we have to see which formula is suitable for that, okay. So we use accordingly, and we also have to very careful when we write the units all has to be in standard form. If here meter and here you see it is in hour, so you have to change the unit. That already I have explained in my class, how you can also, when you see other problems, you will understand, okay. So since here all the units are in standard form, so I did not change any. And when you write the answer, you must mention the unit, otherwise your result may go wrong, okay. So mentioning unit is must, okay. So that's all from this video. I hope you have all understood. If you still find any doubt, you can write in the comment section below. Thank you.